Welcome back again. This time I'm going to introduce a new IoT system project. As usual, this IoT system is part of an assignment for the Internet of Things course at the Sapienza University of Rome. And for this project, we're going to choose the LoRaWAN data network, which is a cloud-based medium access control layer protocol, but acts mainly as a network layer protocol for managing communication between LP1 gateways and end nodes. To start the experiment, using the following command, returning the state of the experiment and more important information like the device's ID. The whole experiment will run on the ST Microelectronics LoRaWAN 1 board where all the application will be executed. We are also going to introduce the Things network and also the IoT-LAB to deploy our experiments. Once again, we're going to use a RIOT application to represent the virtual device publishing random values. So now to make the LoRaWAN station run, we need to download the RIOT application and install RIOT, cloning the GitHub page into the folders. And for this purpose, we're gonna clone my GitHub repository inside the folders too, replacing the existing file into the specific folder. The hands-on tutorial explains clearly how to set up the whole system and how to connect using SSH. Now, after building the LoRaWAN application representing the virtual environment station, use the CLI tools to flash the ST Microelectronics LoRa node, and after we start the application into the IoT-LAB, we need to access the RIOT shell running on the node using netcat, typing these commands, and to properly interact with the LoRaWAN stack running on the node, we need to use the LoRaMAC command. So to connect to the TTN app, we have to copy and paste all the Things network application information. Finally, to configure the TTN application from the IoT-LAB, we need to set a fast data rate, for this purpose 5, corresponding to a bandwidth of 125 kHz. And now that the node has all the required information set, we can join the network using the OTA. Finally, we can start publishing our random values from the LoRaWAN station. Using the MQTT protocol, we need another gateway, which is a Python script, and once again, as usual, to see if the messages are being exchanged. We can start our web application to visualize all the data streamed in the charts, always logging into the localhost 3000. Don't forget to check the hands-on tutorial and the links below of this project, where I will provide full instruction on how to build the IoT system. That's it. Thanks for watching again.